Hello, my dear friends. Elrigu namaskara. Myself, Naveen Kumar, ನಿಮ್ಮ chemistry faculty. I welcome back you all to this incredible platform, physics wala. ಈಗ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಏನ್ ನೋಡಿದೀವಿ, ಏನ್ ಕಲ್ತಿದೀವಿ, ಆಲ್ಕೀನ್ಸ್ ಅಂಡ್ ಇಟ್ಸ್ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಮತ್ತೆ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಎಲ್ಲ ನೋಡಿದೀವಲ್ವಾ. ಲೆಸನ್ ನಂಬರ್ 1 ಅಲ್ಲಿ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಆಲ್ಕೇನ್ಸ್, ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಮತ್ತೆ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿದ್ವಿ. ಲೆಸನ್ ನಂಬರ್ 2 ಅಲ್ಲಿ ಏನ್ ನೋಡಿದೀವಿ, ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಆಲ್ಕೀನ್, ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಮತ್ತೆ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿದೀವಲ್ವಾ. ಈಗ ಇವತ್ತು ಈ ಲೆಕ್ಚರ್ ಅಲ್ಲಿ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಮೀನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ದ ಡೈನ್ಸ್ as well as the preparation of the alkynes as well as the chemical property and the physical property. Now ಇವತ್ತು ಈ ಲೆಕ್ಚರ್ ಅಲ್ಲಿ we are going to see. Clear ಆಯ್ತಲ್ವಾ? Now ಈಗ ಲೆಕ್ಚರ್ ನಂಬರ್ 2 we have seen preparations of the alkene. ಈಗ the preparation of the alkene it will be interlinked with the elimination reactions. Elimination reaction ಈಗ ನೀವು if you are in the first PUC elimination reaction ಅಂದ್ರೆ ಏನು ಅಂತ that you will get to know in the second year or second PUC. But if you are the second PUC and droppers you can easily understand. ಅದರಲ್ಲಿ ನಾನು ಶಾರ್ಟ್ಕಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಈಗ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಡಿಹೈಡ್ರೇಟಿಂಗ್ ಏಜೆಂಟ್ಸ್, ನಾವು ಅದೆಲ್ಲಾನು ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಯಾಕಂದ್ರೆ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಮೇನ್, ಈಗ ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಗುತ್ತೆ, ಬಟ್ ಅದರಲ್ಲಿ ಒಂದು ಡಿಫರೆಂಟ್ ಡಿಹೈಡ್ರೇಟಿಂಗ್ ಏಜೆಂಟ್ಸ್, ಡಿಹೈಡ್ರೇಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ಸ್ ಕೊಡ್ತಾರೆ. ಅದು ಎಲ್ಲ ನಿಮ್ಗೆ ಯು ಡೋಂಟ್ ನೋ ಅದಲ್ವಾ. ಅದಕ್ಕೋಸ್ಕರನೇ ಯು ವಿಲ್ ಫೀಲ್ ದಟ್ ದ ಕೆಮಿಸ್ಟ್ರಿ ಇಸ್ ಸಮ್ವಾಟ್ ಡಿಫಿಕಲ್ಟ್ ಅಂತ ಇನ್ ದಟ್ ಮೇನ್ಲಿ ಆರ್ಗಾನಿಕ್ ಪಾರ್ಟ್. ಅದಕ್ಕೋಸ್ಕರನೇ ನಾನು ವಾಟ್ ಆರ್ ದ ಡಿಹೈಡ್ರೇಟಿಂಗ್ ಏಜೆಂಟ್, ಹೌದು ಏನು ಮಾಡ್ತಾರೆ, ಮತ್ತೆ ಟೆಂಪರೇಚರ್ ಎಲ್ಲಾನು ಟೆಂಪರೇಚರ್ ನಾವು ವೆನ್ ಇಟ್ ವಿಲ್ ಬಿ ಆಕ್ಟ್ ಆಸ್ ಅ ಲೂಯಿಸ್ ಆಸಿಡ್ ಅಂತ, ವೆನ್ ಇಟ್ ವಿಲ್ ಆಕ್ಟ್ ಆಸ್ ಅ ಬ್ರೌನ್ಸ್ಟೆಡ್ ಆಸಿಡ್ ಅಂತ ನಾನು ಎಲ್ಲಾನು reagents ಕೊಟ್ಟಿದ್ದೀನಲ್ವಾ. ದಟ್ ಯು ಕ್ಯಾನ್ ಗೋ ಅಂಡ್ ಸಿ ಓವರ್ ದೇರ್, ದಟ್ ಯು ಕೀಪ್ ಇಟ್ ಒನ್ ನೋಟ್ಸ್ ಅಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ. ಈಗ ಇಫ್ ಯು ರೈಟ್ ದಟ್ ಒನ್ then it will be very good for you and you can easily answer the question whatever they may give in your, it will be helpful for your board exam, it will be helpful for your Neet, it will be helpful for your KCET as well as a JEE mains. Clear ಆಯ್ತಲ್ವಾ? Now let's start our lecture number 3. Now ಈಗ topics to be covered. Iga what are the topics we are going to cover in this today's section? Now the first we are going to see the dienes. Dienes andre enu we are going to see. Next we are going to see the preparation of the alkynes and its physical and the chemical properties. Physical and the chemical properties ಎಲ್ಲಾನು ನೋಡೋಣ. ಡೈನ್ಸ್, ಆಲ್ಕೈನ್ಸ್, ಪ್ರಿಪರೇಷನ್ ಆಫ್ ದ ಆಲ್ಕೈನ್ಸ್, ಫಿಸಿಕಲ್ ಅಂಡ್ ದ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಆಲ್ಕೈನ್ಸ್ ಎಲ್ಲಾನು ಈಗ ಗೋಯಿಂಗ್ ಟು ಸಿ. ಓಕೆ, ನೌ ಈಗ ಫಸ್ಟ್ ಪ್ರಿಪರೇಷನ್ಸ್ ಆಫ್ ದ ಡೈನ್ಸ್. ಈಗ ಡೈನ್ಸ್ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ತ್ರೀ ಟೈಪ್ಸ್ ಆಫ್ ದ ಡೈನ್ಸ್. ನಾವು ಒಂದು ಫಸ್ಟ್ ಈಸ್ ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಡೈನ್. ಫಸ್ಟ್ ಈಸ್ ದ ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಡೈನ್. ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಡೈನ್ ಅಂದ್ರೆ ಏನಂದ್ರೆ ಹಿಯರ್ now carbon it is having, now here this is a cumulative dyne. This is the example for the cumulative dyne. Next we are having the conjugate dyne. Conjugative dyne. Now conjugative dyne ಏನಂದ್ರೆ ಈಗ this is CH2 double bond, C single bond, ಮತ್ತೆ ಇದರಲ್ಲಿ ಮತ್ತೆ this is a conjugative dyne. ಇದರಲ್ಲಿ what is the hybridization of this carbon? This carbon hybridization is sp2. Now this carbon hybridization is also sp2, this carbon hybridization is also sp2, this carbon hybridization is also sp2. ಇದರಲ್ಲಿ one sp2 and one sp carbon. Next we are having isolated dyne. Next is the isolated dyne. Next ಯಾವುದು ಐಸೋಲೇಟೆಡ್ ಡೈನ್. ಐಸೋಲೇಟೆಡ್ ಡೈನ್ ಏನಂದ್ರೆ CH2 ಡೈನ್ CH ನಾವು ಅದರಲ್ಲಿ CH2 ನೆಕ್ಸ್ಟ್ CH ಡಬಲ್ ಬಾಂಡ್ CH2 ಇದರಲ್ಲಿ ನೋಡಿ ನಾವು ಮಿಡಿಲ್ ಕಾರ್ಬನ್ ಎಲ್ಲ ಮಿಡಿಲ್ ಕಾರ್ಬನ್ ನಾವು ದಿಸ್ ಮಿಡಿಲ್ ಕಾರ್ಬನ್ hybridization is sp ನಾವು ಇದರಲ್ಲಿ ದಿಸ್ ಕಾರ್ಬನ್ ಎಲ್ಲ ಕಾರ್ಬನ್ಸ್ hybridization is sp2 ಇದರಲ್ಲಿ ನೋಡಿ ಮಿಡಿಲ್ ಕಾರ್ಬನ್ hybridization is sp3 ಇದರಲ್ಲಿ this carbon hybridization is sp2 this is also sp2 clear now cumulative dienes ಅಂದ್ರೆ same carbon middle carbon having the two double bonds now ಇದರಲ್ಲಿ ಎಲ್ಲ ಕಾರ್ಬನ್ಸ್ hybridization is sp2 isolated dyne ಅಂದ್ರೆ sp2 that sp2 carbon has been separated with the sp3 carbon now this is a cumulative dyne, this is a conjugative dyne, and idralli this is a isolated dyne now idralli in this 3 we are going to see the stability order of the dynes now first stability order alli first we are going to see the conjugate dyne is having the more stable conjugative dyne. Next we are having isolated dyne. Next we are having the cumulative dyne. Stability order alli conjugated dyne alli we can see the delocalization due to the presence of this delocalization conjugative dyne is more stable ಈಗ isolated dyne ಅಲ್ಲಿ this is a isolated dyne alva this is a isolated dyne ಇದರಲ್ಲಿ we can see the delocalization up to here only clear now cumulative dyne now this is a cumulative dyne alva now this is a cumulative dyne clear now cumulative dyne ಈಗ cumulative dyne ಅಲ್ಲಿ ಈಗ ಇದು ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆಯಲ್ವಾ now this hydrogen is not in the planar this hydrogen and these hydrogens are perpendicular to each other this hydrogen ಮತ್ತೆ ಇನ್ನೊಂದು hydrogen perpendicular to each other ಇಲ್ಲಿ ನೋಡಿ ಈಗ if this hydrogens is in this manner ಈಗ ಒಂದು hydrogen ಇಲ್ಲಿದೆ ಒಂದು hydrogen ಇಲ್ಲಿದೆ these hydrogens are perpendicular to each other like this clear ಈಗ perpendicular to each other one hydrogen is above one hydrogen is below now this side these two hydrogens are perpendicular to each other they are not in the same plane this hydrogen both are perpendicular to each other ಅದಕ್ಕೋಸ್ಕರನೇ it is having the least stable now these all are having it is having in the same plane ಎಲ್ಲಾನು sp2 ಅಲ್ವಾ sp2 geometry ಏನು trigonal planar ಅದಕ್ಕೋಸ್ಕರನೇ conjugative dyne is more stable than next isolated and cumulative dyne these are not perpendicular to each other ಈಗ if odd number of double bonds are present then terminal hydrogens ಇದನ್ನ terminal hydrogens ಅಂತಾರೆ terminal hydrogens are parallel to each other okay are parallel to each other ಈಗ if even number of double bonds ಇದೆ ಅಂದ್ರೆ these terminal hydrogens are perpendicular to each other ಇದರಲ್ಲಿ if odd number of double bonds ಇದೆ ಅಂದ್ರೆ ಈ ತರ odd number of double bonds ಅಂದ್ರೆ ಈ ತರ ಈಗ odd number of double bonds ಇದೆ ಅಂದ್ರೆ now these terminal hydrogens are parallel to each other ಈಗ even number of double bonds ಇದೆ ಅಂದ್ರೆ perpendicular to each other clear this is the stability order. Clear ಆಯ್ತಲ್ವಾ? Next. Addition reaction of the 1,3 butadiene, ಅದರಲ್ಲಿ addition of Cl2. Now 1,3 butadiene ಅಂದ್ರೆ this is a 1,3 butadiene ಅಲ್ವಾ? Now this is a 1,3 butadiene of the Cl2. Now ಇದರಲ್ಲಿ 1,3 butadiene ಅಲ್ಲಿ we can see two types of addition. We can see two types of the addition. One is 1,2 addition, ಇನ್ನೊಂದು 1,4 addition. One is 1,2 addition, one is 1,4 addition. Clear? Now Cl2 alva. Now Cl2 it will be divided as the one Cl electropositive. Now here or else. Clear? Now Cl alva. Now Cl it will be divided as the one Cl positive and another will be the electronegative. Clear? Now if I shift this pi bond toward this carbon, let assume 1, 2, 3, 4. This is a 4 number, 1 number carbon, 2 number carbon, 3 number carbon, 4 number carbon. Clear? Now if I shift this pi bond to the 1 number carbon, now 1 number carbon will get the negative charge, arva? 1 number carbon is get the negative charge and the 2 number carbon will get the positive charge. 2 number carbon will get the positive charge. Clear? Now primary carbanion and the secondary carbocation. This is stable. Ega if I shift this pi bond to the 2 number carbon, ನಮಗೆ ಏನು ಬರುತ್ತೆ? Now we'll get a secondary carbanion and the primary carbocation alva. Now this is unstable because primary carbocation and the secondary carbanion is unstable. ಅದಕ್ಕೋಸ್ಕರನೇ we will shift the pi bond toward the 1 number carbon so that we are getting the stability of primary carbocation and the stability of primary carbocation as well as the we will shift the so we will not shift the pi bond to the 2 number carbon. We will shift the pi bond to the 1 number carbon only. Clear ಆಯ್ತಲ್ವಾ? Now this Cl positive will go and attack here and this Cl minus will go and attack here and will get the Cl here and another Cl. Clear? Now this is a 1,2 addition. Clear? 1,4 additionally resonance or else delocalization will be happened. Now will nodi. Clear? Now first now what I am doing, now I am shifting this pi bond to here. Now innondu this pi bond will be shifted toward this carbon. Now give the numbering. This is 1 carbon, this is 2 carbon, this is 3 carbon, this is 4 carbon alva. Now what will get? Now 1 carbon will get the positive charge. Now 4 carbon will get the negative charge. Now this is 1 carbon will get the positive charge and the fourth carbon will get the negative charge alva. Now idralli Cl positive will go and attack here and the Cl negative will go and attack here and will get the product 1,4 addition. Now this is a 1,4 addition. This is 1,2 addition. Idralli this is 1,4 addition. 1,2 addition idralli this is a 1,4 addition. Okay? Next. ಈಗ if same 1,3 butadiene addition of HX addition of hydrogen halide ಕೊಟ್ಟಿದ್ರಂದ್ರೆ without peroxide ಕೊಟ್ಟಿದ್ರಂದ್ರೆ it will follow the Markovnikov rule. Clear ಆಯ್ತಲ್ವಾ? Now addition of hydrogen halide ಈಗ addition of hydrogen halide ಕೊಟ್ಟಿದ್ರಂದ್ರೆ without peroxide it will follow ಮಾರ್ಕೋನಿಕಫ್ ರೂಲ್. ವಿತ್ ಪೆರಾಕ್ಸೈಡ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಇಟ್ ವಿಲ್ ಫಾಲೋ ದ ಆಂಟಿ ಮಾರ್ಕೋನಿಕಫ್ ರೂಲ್ ಅಲ್ವಾ. ಇದರಲ್ಲಿ ವಿತೌಟ್ ಪೆರಾಕ್ಸೈಡ್ ಕೊಟ್ಟಿದ್ರಲ್ವಾ. ದೆನ್ ಇಯರ್ ದ ಎಫೆಕ್ಟ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಪ್ಲೇ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್. ಎಫೆಕ್ಟ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಪ್ಲೇ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್. ಈಗ 1,2 ಅಡಿಷನ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಈಗ ಲೋ ಟೆಂಪರೇಚರ್ at the low temperature it will be dissociate as a H plus and the X minus alva. Now if it is a minus 40 degree, ಈಗ minus 40 degree ಅಂತ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now 1,2 addition is stable. 1,2 addition is stable. 1,2 addition is stable and kinetically stable. 1,2 addition is kinetically stable at the low temperature. Now the product ಏನು ಬರುತ್ತೆ? Now clear? Now this is 1,2 addition alwa. ಇದರಲ್ಲಿ ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಹೈಡ್ರೋಜನ್, ನಾವು ಇದರಲ್ಲಿ ಎನಿ ಹ್ಯಾಲೋಜನ್. ಕ್ಲಿಯರ್? Now at low temperature which is stable, kinetically stable, 1,2 addition is stable. Clear? Now 1,4 addition ಯಾವಾಗ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ? If you increase ಇದರಲ್ಲಿ when you did the reaction at minus 40 degree ನಮಗೆ this product has been came alwa. Now this is a major product. 1,2 addition product is a major. ಈಗ for this one ನಾನೇನ್ ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ ಈಗ ನಾನು ಫಸ್ಟ್ ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು ಮೇಂಟೈನ್ ಮಾಡಿದ್ದೀನಿ? 40 degrees ಮೇಂಟೈನ್ ಮಾಡಿದ್ದೀನಲ್ವಾ. ಈಗ if I increase the temperature to the plus 40 degree, ಈಗ if I increase the temperature to the plus 40 degree, now ಈಗ at the low temperature 1,2 addition product major ಆಯ್ತಲ್ವಾ. now when I increase the temperature ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 1,4 addition product will become the major. 1,4 addition product will become the major. Clear? ಅದಕ್ಕೋಸ್ಕರನೇ at high temperature 1,4 addition is major. now at low temperature 1,2 addition is major. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಓನ್ಲಿ ಅಡಿಷನ್ ಆಫ್ ದ HX ಹೈಡ್ರೋಜನ್ ಹ್ಯಾಲೈಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್ ದೇ ಮೇ ಆಸ್ಕ್. ಈಗ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಈಗ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್ ದೇ ಮೇ ಆಸ್ಕ್. ನೌ when you add hydrogen halide, when you add the hydrogen halide to the 1,3 butadiene, kinetically stable product is stable at which temperature ಅಂತ ಕೇಳ್ತಾರೆ. ಓಕೆ, now at low temperature kinetically stable product 1,2 addition. Now at high temperature 1,4 addition thermodynamically stable. Clear ಆಯ್ತಲ್ವಾ? Now the first reaction is going with the minus 40 degree. Now this is the major. Now ಆವಾಗ ಈಗ ಈ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತಲ್ವಾ. ನಾವು ಈಗ ಈ ಪ್ರಾಡಕ್ಟ್ ನಾನು ಈಗ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ದೇನೆ ಅಂದ್ರೆ 1,4 addition is a major. 1,4 addition is a major. Clear? Now clear, but effect of temperature it will not be applicable for the Cl2. Here this will follow the Markovnikov and the anti-Markovnikov rule. Now this was stabilized by the resonance. This is without resonance. Okay, next. Now we'll see the alkynes. The alkynes general formula ಏನು? CnH2n minus 2. General name is acetylene. ಇದು ನೆನಪಿಟ್ಕೋಬೇಕು. Sometimes they may give directly they may give this name. Now what is the general name of the alkanes? General name of the alkanes is paraffins, alkenes, olefins. Now general name of the alkynes acetylene. This is the first number of the alkane. Clear? Now functional group is triple bond. Hybridization is sp. Now carbon triple bond, carbon bond length is 1.20 angstroms. This is the basic information of the alkanes. Structure of triple bond. ಈಗ structure of triple bond ಏನಂದ್ರೆ this is triple bond ಅಲ್ವಾ? This is triple bond. ಈಗ ಈ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೇಷನ್ ಏನು? This carbon hybridization is sp. ಈಗ ಈ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೇಷನ್ ಏನು? sp ಅಲ್ವಾ? Now this is sigma bond. Now 1 pi bond. ಈಗ carbon single bond carbon or sigma bond. This sigma bond carbon is formed by the overlapping of sp and the sp. By sp hybridized overlaps leads to give the sigma bond. Now clear? Now here carbon 2 pi bonds ಇದೆಯಲ್ವಾ? 2 carbon pi bonds is formed by the overlapping of pure p orbitals. This is pure p orbitals. Pure p orbitals sideways overlaps leads to give the pi bonds. ಈಗ ನಿಮಗೆ ಕ್ಲಿಯರ್ಲಿ ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ you have to see the chemical bonding chapter. ಈಗ chemical bonding chapter, if you see, you will get to know the structure of the triple bond. Triple bond. Clear? Now this carbon, 2 carbon and the hydrogen sigma bond is formed by the overlapping of sp and the s. Sp and the s. Clear? This is formed by the overlapping of the orbital. Now this is sp hybridized carbon alva. sp hybridized carbon alva. Now here this information is very important. CH3 ಇದರಲ್ಲಿ this carbon hybridization is sp3. Okay, next CH2 double bond CH2. Okay, ಇದರಲ್ಲಿ ಈ carbon hybridization is sp2. ಇದರಲ್ಲಿ this carbon hybridization is sp2. Next carbon triple bond carbon alva. Now this carbon hybridization is sp. This carbon hybridization is sp. Clear? Now here if the percentage s character is increased, electronegativity increase. ಈಗ electronegativity increase ಅಂದ್ರೆ among these three which is more electronegative? Triple bond is more electronegative, then double bond, then single bond. ಇದರಲ್ಲಿ sp ಅಲ್ಲಿ percentage s character ಎಷ್ಟು 50. Clear? Now sp2 ಅಲ್ಲಿ percentage s character ಎಷ್ಟು 33.3. Clear? Now percentage s character in the sp3, that is 25. Clear? Now ಈಗ percentage s character increase ಅಂದ್ರೆ electronegativity increase ಅಂದ್ರೆ, now here this is electronegativity. Triple bond is having the more electronegativity than the alkane. Alkane ಅಲ್ಲಿ alkynes is the more electronegative. This carbon sp hybridized carbon is a more electronegative. This information you should know. Okay, ಈ ಇನ್ಫಾರ್ಮೇಶನ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? Now sp hybridized carbon is more electronegative. Clear? ಈಗ preparations of the alkynes. Now first we can prepare from the calcium carbide. ಈಗ in the industrial purpose ಅಲ್ಲಿ, now how we can prepare the acetylene ಅಂದ್ರೆ, first we can prepare from the calcium carbide. ಈಗ calcium carbide ಹೆಂಗ್ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, first calcium carbide ನ heat ಮಾಡಿದಾಗ what we are getting the calcium oxide, and this calcium oxide when it is treated with the coke, this carbon coke, we are getting the calcium carbide. ಈಗ ಈ calcium carbide when we are treating with the water, we are getting the calcium hydroxide and we are getting the acetylene. ನೋಡಿ, this is the calcium carbide. Now calcium carbide. Now this is metal always will be stable in the metal, always it will be present in the electropositive nature alva. Metal always it will be shown in the electropositive nature and it will be divided into like this. Clear? Now here this calcium carbide ion plus H2O gives rise to the acetylene, and that when it is reacting with the water, and we are getting the 2 moles of hydroxide ion. By this we are getting the, when it is treated with the calcium carbide, we are getting the acetylene, we are getting the ethine, or else acetylene or ethine. Iga if you want to prepare the propane, we have to take the magnesium carbide. Iga with the magnesium carbide we can prepare the propane. Okay, with the calcium carbide we can prepare the ethine. Propane can be prepared by the magnesium carbide. Iga magnesium carbide it will be dissociate to the 2 Mg plus 2 and C34 minus. Iga this will be C minus 3 charge and the minus, and we are having the 4 moles of H2O. Your 4 moles andre we are having the 4H plus alva, 4H plus, and it will be CH3 and C triple bond CH plus 4 OH minus, 4 OH minus. Clear? Now the propine can be prepared by the magnesium carbide. Propine can be prepared from the magnesium carbide. Now ethyne can be prepared by the calcium carbide. Clear? This you have to remember. Now next from vicinal dihalides. ಈಗ vicinal dihalides ಇಂದನು we can prepare the alkanes. Now ಹೆಂಗಂದ್ರೆ ಈಗ ಇದು ಎಲ್ಲಿ ನೋಡಿದೀವಿ, ಆಲ್ಕೈನ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಲ್ವಾ, ಆಲ್ಕೀನ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಲ್ವಾ. ಆಲ್ಕಿನ್ಸ್ ಅಲ್ಲಿ ಡಿಹೈಡ್ರೋ ಆಲೋಜಿನೇಷನ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಲ್ವಾ. ಡಿಹೈಡ್ರೋ ಆಲೋಜಿನೇಷನ್ ಅಲ್ಲಿ ಏನ್ ನೋಡಿದೀವಿ. Now this is small base alcoholic KOH. This is a small base. It will follow the E2 elimination. Now the hydrogen and the one halogen will be eliminated in the anti-elimination. Andre, now the base readily will take the hydrogen. From the internal carbon. Yakandre internal carbon in the hydrogen it has taken. Now here we will getting the more substituted alkene. Set job product will get alva that we have seen in the alkane. More set job product will get. More set job products andre more number of alpha hydrogen. More number of alpha hydrogens andre more hyperconjugation. ಈಗ more hyperconjugation ಅಂದ್ರೆ more stability. ಅದಕ್ಕೋಸ್ಕರನೇ small base readily take the hydrogen from the internal end. ಈಗ bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ it will take the hydrogen from the terminal end ಅಂದಲ್ವಾ. ನಾವು ಈಗ ನೀವು ನೋಡಿಲ್ಲ ಅಂದ್ರೆ alkanes ಅಲ್ಲಿ you can see there I explained very clearly. Okay, now anti elimination andre this will be, now ಇದರಲ್ಲಿ two bases ಇದೆಯಲ್ವಾ. Two bases. One is first with the alkali KOH. Now with the alkali KOH, now this hydrogen will be, now this bond will be delocalized here. Now this bromine is a good leaving group alva. Bromine is a good leaving group. Halogen, strong acids conjugate bases are the good leaving group alva. Now by that what will get. Now, this is methyl. Clear? Now idaralli here we are having one hydrogen, or else write like this. Clear? Now this is the one product we are getting with the alkalic OH. Next we are having sodium amide. Now in the presence of liquid ammonia, this will also small base. Now this will also follow the anti-elimination alva. Now this bond will be delocalized and the bromine will be eliminated and we will get the triple bond alva. Now we are getting the triple bond like this. Clear? Now by this also we can prepare the alkane. Clear? Now this is alkalic OH readily will take the hydrogen from the internal terminal carbon. Now this will be follow the anti-elimination, the elimination of the HBr. Now this elimination we call it as the anti-elimination. Now this will follow the E2 elimination. Clear? E2 elimination, this is a concerted reaction. There is no intermediate. This hydrogen will be shifted here and this bromine will be eliminated. Yakandre bromine is a good leaving group. There is no any intermediate. In the alkanes alli nodidivalva, ಏನು ನೋಡಿದೀವಿ. Now dehydration reaction, dehydration of alcohols alli now concentrated H2SO4 at the high temperature ಏನು ನೋಡಿದೀವಿ. ಅದರಲ್ಲಿ first intermediate is formed. Then we have shifted and arranged the stability of the carbocation ನೋಡಿದೀವಲ್ವಾ. that it is following the even mechanism. That even mechanism non concentrated reaction. Non concentrated ಅಂದ್ರೆ there is intermediate. ಇದರಲ್ಲಿ there is no intermediate. ಅದಕ್ಕೋಸ್ಕರನೇ directly we are getting the alkane. Clear? Now with the alkalic KOH and the NaH sodium amide in the presence of liquid ammonia, we are getting the alkane. Now this is the preparations of the alkanes. Next, ಈಗ properties of the alkanes ಏನಂದ್ರೆ C1 carbon to C4 carbons are the gaseous, C1 to C3 carbons are gaseous, C4 to C8 are the liquids and C9 above are the solids. solids. ಈಗ melting points, boiling points are increases with the higher masses. ಈಗ ಮಾಸ್ ಆಲ್ಕೈನ್ಸ್ ಅಲ್ಲಿ ಈಗ ಮಾಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಈಗ ಮಾಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಲೆಟ್ ಅಸ್ಯೂಮ್ ದಿಸ್ ಇಸ್ ಟ್ರಿಪಲ್ ಬಾಂಡ್. ನೋ ನೆಕ್ಸ್ಟ್ CH3 C ಟ್ರಿಪಲ್ ಬಾಂಡ್ CH. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ದಿಸ್ ಸರ್ಫೇಸ್ ಇಸ್ ಸ್ಮಾಲ್, ಬಟ್ ಇದರಲ್ಲಿ ಸರ್ಫೇಸ್ ಇಸ್ ಜಾಸ್ತಿ ಅಲ್ವಾ. ನಾವು ಈಗ ಇದು ಹೀಟ್ ಮಾಡೋಕೆ ಜಾಸ್ತಿ ಹೀಟ್ ಇಟ್ ವಿಲ್ ಅಬ್ಸರ್ವ್ ಅಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರನೇ ವೆನ್ ದ ಹೈಯರ್ ಆಲ್ಕೇನ್ಸ್ ಆರ್ ವೆನ್ ದ ಹೈಯರ್ ಮಾಸ್ is increased, melting point and the boiling point increases with the higher mass. But this you have to remember, C1 to C3 carbon are gases, C4 to C8 are the liquids, C9 above are the solids. Okay, next ಈಗ next chemical properties of the alkane. ಈಗ chemical properties of the alkanes ಅಲ್ಲಿ acidic character of the alkynes, acidic characters of the alkanes. Now this alkyne, this ethane or acetylene, when it is reacted with the metal, now this sodium amide and the sodium amide and the sodium metals are the strong bases alva. Now this strong bases when it is reacted with the alkene and the alkyne, when it is reacted with the alkene and alkyne, now these two are not reacted with the more strongly it has not reacted with the sodium as well as the sodium amide. It has not readily given the H plus, but when it is reacted with the two has not readily given the H plus to the solution. When they are not readily given the H plus to the solution andre these are less acidic. But why only the alkane is more acidic andre, when these strong bases, when this alkane is reacting with these strong bases, it is readily given the H plus to the solution. The one which readily give the H plus to the solution adane anತಾರೆ strong acid anತಾರೆ. Clear? Now ಇದರಲ್ಲಿ HCl ಮತ್ತೆ H2SO4, why we are saying this as a strong acids, ಯಾಕಂದ್ರೆ this will readily give the H plus to the solution. The one which readily give the H plus to the solution adine anತಾರೆ acids anತಾರೆ. Clear alva? Now in the same way when these strong bases, when it is reacting with this alkane and the alkane, this is not giving the hydrogen readily to the solutions. Now but when it is giving to the acetylene, now this carbon hybridization is sp alva, sp. Now this is more electronegative carbon. When this hydrogen is eliminated, when this hydrogen is given to the solution, now ee carbon mele ಏನು ಬರುತ್ತೆ, this carbon will get the negative charge alva. Now if this eliminated as a proton, now ಈಗ ಈ carbon ಮೇಲೆ ಏನು ಬರುತ್ತೆ, what it will get, negative charge will get. Now more electronegative atom bearing the negative charge is stable. ಅದಕ್ಕೋಸ್ಕರನೇ this hydrogen readily given to the solution ಅಂದ್ರೆ this hydrogen is acidic hydrogen. ಅದಕ್ಕೋಸ್ಕರನೇ this hydrogen is a acidic hydrogen. This is acidic hydrogen. Clear ಆಯ್ತಲ್ವಾ? ಅದಕ್ಕೋಸ್ಕರ this is readily giving the solution. When it is readily giving the hydrogen to the solution, this carbon is getting the negative charge, but this negative charge is more stable on this carbon. ಯಾಕಂದ್ರೆ this sp carbon is more electronegative, more electronegative atom bearing the negative charge is stable. ಅದಕ್ಕೋಸ್ಕರನೇ this is readily given to the solution, and we'll get the monosodium ethanide. When it is given the H plus, now this will get the positive. Now sodium always it will be in the which one, electropositive nature alva. Readily it will lose the electron, and it will be in the electropositive nature. Now this, and it will evolve the hydrogen gas, Clear? Next, even though when it is reacting with the sodium amide, also it will readily given to the solution, and the sodium amide, when it is reacted, and the sodium will be attacked here, and will getting the sodium propionide, and the ammonia is this H plus. This H plus will go and attack to this NH2, and it will form the it will form the ammonia. It will form the ammonia. By this we got to know that acetylene hydrogen is a acidic hydrogen. Acetylic hydrogen is a more acidic hydrogen. Now ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಈ ಎರಡಲ್ಲಿ 1 2 among the 1 and 2 which one is having the more acidic hydrogen ಅಂತ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ which one is having the more hydrogen ಅಂತ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ more acidic hydrogen. Now among this 1 and 2 more acidic hydrogen is present in the 1 than the 2 ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ here this negative charge is more stable on this carbon alva, more stable on this carbon when it is readily given to the solution. Now here due to the presence of this plus I group, now iga already this carbon is bearing the negative charge. Iga if this proton is given to the solution, now iga ee carbon mele en barutte negative charge barutalva. Now here this group present here, it is a plus I group. What is the role of the plus I group? It will give the electron releasing group alva. Now already this carbon is having the excess of electron. Now by giving the more excess of electron, it will become unstable alva. It will become unstable. When it will become the unstable, when it will become the more negative charge, when it will become the unstable, now ee carbon ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ whatever the hydrogen given to the solution, again it will be restored it. By that it will not give the hydrogen to the solution very fastly. But idralli there is no any plus I groups is attached. Adigoskara this will readily give the hydrogen to the solution. Clear? If the plus I groups increase, acidic nature of the triple bond it will be decreased. Clear aitalva? Now among the 1 and 2 which is having the more acidic hydrogen andre 1 is having the more acidic hydrogen. Now methyl group is a plus I group. Clear? No. Reactivity order ನೋಡಿದೀವಲ್ವಾ? reactivity. Now bond length. ಈಗ bond length ನೋಡಿದೀವಿ ಅಂದ್ರೆ bond length ನೋಡಿದೀವಿ ಅಂದ್ರೆ first carbon single bond carbon is having more bond length. Next carbon double bond carbon. Next carbon triple bond carbon. Clear ಆಯ್ತಲ್ವಾ? Next acidic nature ನೋಡಿದೀವಿ ಅಂದ್ರೆ carbon triple bond carbon hydrogen is more acidic than carbon double bond carbon. Next carbon single bond carbon hydrogen. Clear? Now ಈಗ acidic hydrogen order ಅಂತ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ 3 triple bond 3. Next propine. Next clear? Now among these three which is having the acidic hydrogen andre now iga if plus I groups increases acidic nature of the hydrogen of the alkyne it will be decreases alva, it will be decreases. Okay, it will be decrease. Yes. Okay, clear? Now next ಇನ್ನೊಂದು addition reaction of the dihydrogen. ಈಗ ಫಸ್ಟ್ ಲೆಕ್ಚರ್ ಅಲ್ಲಿ ನೋಡಿದೀವಲ್ವಾ preparations of the alkanes. Now with the metal by hydrogen. Now this hydrogens will be absorbed on this metal. This will be absorbed on this metal. Now these absorbed metal hydrogens, these hydrogens will be absorbed on the metal and it will be attacked to give the alkyne. It will give the alkane. Clear? Now ಈಗ if you keep any poison ಇದರಲ್ಲಿ if you keep the any poison now CH plus H2. now ಈಗ if you maintained any poison palladium or the in the presence of barium sulfate now or poisoned S or quinoline poisoned S or quinoline if you maintain now it will stop the reaction at the reaction at the which alkene stage. If we stop the, ಈಗ if you maintain the poisoned sulfur or quinoline, ಈಗ ಇದು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ it will stop the reaction at the alkene stage. If there is no any poisoned sulfur or quinoline, it will directly convert the alkyne to the alkane. Clear? If you maintain the poisoned sulfur or the quinoline, it will stop the reaction at the alkene stage. This we have seen in the Lindlar's catalyst alva. Now this is a Lindlar's catalyst. Lindlar's catalyst ಏನ್ ಮಾಡುತ್ತೆ, alkynes, it will stop the reaction at the alkene. In the alkenes ಈಗ ನೋಡಿದ್ದೀವಿ ಅಲ್ವಾ. Now this is the addition reaction of the dihydrogen. ಈಗ if there is no any poisoned sulfur or anything, directly it will convert into the alkane. Clear? Now next, addition of the halogens. ಈಗ addition of the halogens, this is used to test for the decolor, this is used to test for the unsaturation. This is used to test for the unsaturation. ಹೆಂಗಂದ್ರೆ now reddish orange color of the bromine solution is decolorized in that, it is decolorized in the carbon tetrachloride. By this we can, this is used to test for unsaturation. This is test for the unsaturation. Now ಈಗ whatever the reddish orange color of the bromine, that is decolorized in the carbon tetrachloride alva. Now so that by that we can get to know that in the given solution there is a unsaturation, there is a double bond or the triple bond. Clear? Now ಈಗ Br2 in the presence of carbon tetrachloride, it will be converted into Br plus and the Br minus. ಈಗ when this pi bond, now this will convert into the cyclic bromonium ion. Now this will be, when this it will be come contact to this pi bond, now bromine, now this will form the bond. ಯಾಕಂದ್ರೆ this bond will be shifted here, and this will form the cyclic bromonium ion. Now this, when it is formed the cyclic bromonium ion, now this bromine is loss of its electron alva, adugoskaraನೆ we have given this bond pair of electron toward this bromine. When we have given the bond pair of electron toward this bromine, by that this carbon is getting the positive charge. Now idaralli we are having the Br minus alva, that electronucleophile will go and attack to this carbon deficient carbon. Clear? This deficient carbon, this nucleophile will go and attack to this carbon deficient carbon. Clear? Next, by that we will get again we are having the Ba2 in the presence of CCl4. Clear? We are having the 2Br2 in the presence of CCl4. Clear? Now ಇನ್ನೊಂದು bromine ಇದೆಯಲ್ವಾ, now same reaction it will be happen, same ಇದರಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇದೆಯಲ್ವಾ. ನಾವು ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ಆಲ್ಸೋ ವೀಕ್ಲಿ ಹೆಲ್ಡ್, ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಬಿ ಅಟ್ಯಾಕ್ಡ್ ಟು ದಿಸ್ ಬ್ರೋಮಿನ್, ಅಗೇನ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ವಾ. ನಾವು ಇದೇನು 2,2 3 ಸಾರಿ 1,1 2,2 1,1 2,2 ಟೆಟ್ರಾಬ್ರೋಮೋ ಏನು 1,1 2,2 ಟೆಟ್ರಾಬ್ರೋಮೋ ಈಥೇನ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್, ಅಡಿಷನ್ ಆಫ್ ಹ್ಯಾಲೋಜನ್ಸ್. ಈಗ ಪ್ರೊಪೈನ್ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ now what it will happen, now this pi bond will be shifted. now ಯಾಕಂದ್ರೆ it will not shift toward this carbon. ಈಗ if it is shifted toward this carbon, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, if this is shifted toward this carbon, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, here this is CH3, now this is minus, now this is positive, and this is hydrogen alva. Now this is secondary carbanion. Secondary carbanion is unstable because due to the presence of these plus I groups, it will destabilize this carbon. Adugoskaraನೆ this pi bond should be shifted towards the one number carbon only. It should shift toward the one number, or if it is a one number, pi bond should be shift toward the one number carbon only. It should not shift to the two number carbon. Clear? Now CH3, CH positive, double bond. Now this is H and this is negative alva. Now here we are having the Br positive and the Br negative. Now one will be go and attack here and the one will be go and attack here, and we'll get the CH3. See, bromine, double bond, another bromine. Now H alva. Now see, again Br2 in the presence of CCl4. Again it will present in the Br2 the CCl4. Now the CH3, see, Br. Now the double bond. Now Br. Now H alva. Now again this pi bond should be shifted toward this carbon only. Yakandre if it is a negative charge, it will destabilize the carbanion alva. Now here CH3, C Br, C Br. Now this is H. Now this is positive, this is negative. Clear? Again they are having the Br positive. Again the ring it will be formed alva. Ring it will be formed. Now again the cyclic, same process. ಈಗ mechanism ನೋಡಿದಿವಲ್ವಾ, cyclic bromonium ion it will form. Again it will be delocalized, or again this it will give the bond pair of electron. It will be given. Now again we'll get like this CH3. Now this is CH3. Sorry. Now idರಲ್ಲಿ we'll get the CH3. C Br. Now here one Br will be attacked. Now here one Br will be attacked. Here the one Br will be attacked. Now here will be the H. Clear? Now this is 1, 1, 2, 2 tetrabromopropane. 1, 1, 2, 2 tetrabromopropane. Now this is a final answer. Clear? Now next. ಈಗ ಅಡಿಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಹ್ಯಾಲೈಡ್ಸ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, ಹೈಡ್ರೋಜನ್ ಹ್ಯಾಲೈಡ್ಸ್ ಅಂದ್ರೆ ಏನು? ದಿಸ್ ಇಸ್ H ಪ್ಲಸ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ X ಮೈನಸ್ ಅಲ್ವಾ? ದಿಸ್ ಇಸ್ H ಪ್ಲಸ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ X ಮೈನಸ್. ನೌ ದಿಸ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕಲ್. ನೌ ಈಗ if you take the propane, if you take the ethane, this is symmetrical. Either pi bond can be shifted towards this 1 carbon or the 2 carbon. Clear? ಈಗ if it is shifted towards the H. Now this is negative, this is positive alva. Now hydrogen will go and attack here. Now the X will go and attack here alva. Now next hydrogen. Now idaralli this is X. Now double bond. This is CH2. Clear? Now again the double bond idi alva. Now HX. Now again this pi bond will be shifted towards this carbon. Now this pi bond will be shifted towards this carbon. Now enagutte? Now this is X. Now this is now this is CH2 minus. Now this is positive. Now this is H. Clear? Again we are having the H plus and the X minus. Now this X minus will go and attack here, and the H plus will go and attack here. Now we'll get the CH3. See, this is a geminal dihalide. Now this is a geminal dihalide. Yakandre, now when the halogens are attached to the same carbon, then we can say it as a geminal. This we call it as a geminal. Okay. Next. Iga if you have taken the propine, CH3, C triple bond, CH in the presence of HX. Now what you will get? Now iga pi bond will be shifted toward this carbon alva. Now yakandre idralli negative charge is unstable. Carbanion is unstable. Now double bond idralli CH. This is negative. This is positive. H plus and the X minus alva. Now X minus will go and attack here. Now this H plus will go and attack here, and what will get? CH3, C X. Now C double bond, CH2. Now again we are having the H plus and the X minus. Now again this pi bond will be shifted. Now CH3, now X. Now here the CH2 minus idralli positive charge alva. Now X minus will go and attack here. Now H plus will be go and attack here, and we are getting the CH3, CX. So CX, and this is CH3. Clear? Now we are getting the geminal dihalides. By the addition of HX, we are getting the geminal dihalides. Okay. Now vicinal andre if these two halides are attached to the two different carbon, this we can say it as a vicinal. If halides are attached to the same carbon, we'll get the geminal. Clear? Next. Addition of water. Now ಈಗ this is very very important. Addition of water. ಈಗ addition of water ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ they will ask IUPAC name of the product. IUPAC name of the product. Clear? ಈಗ if they have given the what is this? If they have given the acetylene or ethine ಈಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now this pi bond can be shifted here. Pi bond can be shifted here. Now we are having the positive and the OH minus alva. Now here H, this is double bond. Now this is H. Now this is negative. This is positive. Clear? Now this OH minus will go and attack here. Now the H plus will go and attack here, alva. Now next, ಇದರಲ್ಲಿ COH. Now this is H. Now this is double bond CH. Now this is in the form of enol. This is in the form of the enol. Enol is the unstable. Enol is the unstable. When the enol is the unstable, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ tautomerization 1,3 proton transfer will takes place. ಅದನ್ನೇನಂತಾರೆ tautomerization 1,3 ಇದರಲ್ಲಿ this bond will be shifted here and this pi bond will be shifted here. Now here the tautomerization will be happened 1,3 proton transfer. 1,3 proton transfer ಏನಂತಾರೆ tautomerization ಅಂತಾರೆ. Clear? Now here H. Now C double bond O and CH3. Clear? Now this is a product. This is a product. Clear? This is a product. Now next, ಈಗ propine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ if they have given propine. Now propine ಈಗ ethyne ಕೊಟ್ಟಿದ್ರಂದ್ರೆ aldehyde we got alva. Now propine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now the pi bond will be shifted here. Now same CH3 C positive C double bond CH minus. Now here H plus OH minus alva. Now H plus will go and attack here and the OH minus will go and attack here and we'll get the CH3 C. ಇದರಲ್ಲಿ ಏನು ಬರುತ್ತೆ OH double bond CH2. Clear? Now ಇದರಲ್ಲಿ this is the enol. Enol is the unstable alva. Now this is in the form of enol content. Enol is a unstable. Now ಏನಾಗುತ್ತೆ ಇದರಲ್ಲಿ tautomerization ಆಗುತ್ತೆ. Tautomerization ಅಂದ್ರೆ 1,3 proton transfer. 1,3 proton transfer. 1,3 proton transfer. 1,3 proton transfer tautomerization ಆಗುತ್ತೆ. Now this bond will be shifted here. Now this bond will be shifted here and here the CH3 C double bond O and here it is a CH3. Now here we are getting the this is acetone. This is we are getting the acetone. Clear? ಈಗ propine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ we are getting the ketone. Ethine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ we are getting the aldehyde. Ethine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ we are getting the aldehyde. You have to be very careful. ಇದರಲ್ಲಿ this is the enol. Enol is unstable. Now ಇದರಲ್ಲಿ tautomerization ಆಗುತ್ತೆ 1,3 proton transfer. ಇದರಲ್ಲಿ 1 2 3 1,3 proton transfer. 1,3 proton transfer ಅಂದ್ರೆ when this bond is shifted here, now this will having with the positive charge alva. Now when this pi bond has been shifted toward this carbon, ಈಗ ಕಾರ್ಬನ್ ಮೇಲೆ ಏನು ಬರುತ್ತೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ವಾ. ನಾವು ದಿಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ವಿಲ್ ಗೋ ಅಂಡ್ ಅಟ್ಯಾಕ್ ಹಿಯರ್ ಅಂಡ್ ವಿಲ್ ಗೆಟ್ ದ ಆಲ್ಡಿಹೈಡ್. ಈಗ ಇಥೈನ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಆಲ್ಡಿಹೈಡ್, ಪ್ರೊಪೈನ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಎಸಿಟೋನ್. ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಪಾಲಿಮರೈಸೇಷನ್ ಅಲ್ಲಿ ಪಾಲಿಮರೈಸೇಷನ್ ಅಲ್ಲಿ ಈಗ ಈ ತರ 3 moles of propines ಕೊಟ್ಟಿದ್ರಂದ್ರೆ 3 moles of propines ಕೊಟ್ಟಿದ್ರಂದ್ರೆ red hot in the iron tube at a high temperature, with the propine 3 moles of the propine ಇವಾಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ what we will get ಅಂದ್ರೆ one pi bond will be shifted here, one pi bond will be shifted here, and we'll get the like this acetylene. We'll get the acetylene CH3. Directly we'll get the benzene ತರ. Clear? ಈ ತರ propine ಕೊಟ್ಟಿದ್ರಂದ್ರೆ we are getting the acetylene. Now next if they have given in this manner, if they have given ವಾಟ್ ಈಗ ಅವರು ಎಸಿಟಲಿನ್ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ 3 moles ಆಫ್ ಎಸಿಟಲಿನ್ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ ಇನ್ ದ ರೆಡ್ ಹಾಟ್ ಐರನ್ ಟ್ಯೂಬ್ at high temperature. Now what we'll get? We'll get the benzene. Now this pi bond will be shifted here, this pi bond will be shifted here, and we'll get the benzene. We'll get the benzene like this. Here the hydrogen, 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 here the hydrogen. Clear? Now ಈಗ ಪ್ರೊಪೈನ್ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ 1,3,5 trimethyl benzene. Clear? ಈಗ if they have given the what is this acetylene or ethyne ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ we are getting the benzene. Clear? ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ರೆಡ್ ಹಾಟ್ ಐರನ್ ಟ್ಯೂಬ್ at the high temperature we are getting the benzene. ನೆಕ್ಸ್ಟ್ ಓಝೋನಾಲಿಸಿಸ್. ಈಗ ಓಝೋನಾಲಿಸಿಸ್ ಅಂದ್ರೆ ದಟ್ ಆಲ್ಕೇನ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಲ್ವಾ, ದಿಸ್ ಓಝೋನಾಲಿಸಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಏನಿಲ್ಲ, ಜಸ್ಟ್ ಯು ಬ್ರೇಕ್ ದ 2 double bonds and put the oxygen. Now first we'll get this ozonide upon we are breaking upon hydrolysis we are getting the glycol. Clear? By breaking this double bond, now ಏನು ಬರುತ್ತೆ ಡೈರೆಕ್ಟ್ಲಿ CH. now double bond alwa, this is oxygen, now here carbon and this carbon and here oxygen. now ಈಗ ಈ ಕಾರ್ಬನ್ ಗೂ ಡಬಲ್ ಬಾಂಡ್ ಇದೆ ಅಲ್ವಾ, now same we are getting the glyoxal. Clear? By breaking this double bond. But alkanally break entire double bond, but in this alkanally only break these 2 double bonds and put the oxygen. Now we'll get the glyoxal. Now glyoxal and we are getting the hydrogen peroxide. Now this is a mild oxidizing agent. Now this will play very important role. Clear? Now in the ozonolysis triple bond ಮತ್ತೆ ಡಬಲ್ ಬಾಂಡ್ ಅಲ್ಲಿ ಈಗ ಓಝೋನಾಲಿಸಿಸ್ O3 plus Zn ಕೊಟ್ಟಿದ್ರಂದ್ರೆ reaction for the double bond it will stop the reaction at the aldehyde state. When this zinc will destroy the hydrogen peroxide. ಈಗ this zinc will destroy the hydrogen peroxide. ಈಗ zinc ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ now this is a mild oxidizing agent ಅಲ್ವಾ. ನಾವು ಈಗ ಇದೇನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ directly it will be this glyoxal, it will be oxidized to this formic acid. ಈಗ this formic acid is unstable, again it will be oxidized to the CO2 and again it will be oxidized to the CO2. Clear? Now ಈಗ if they have given a zinc, ಈಗ ಅವರು zinc ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now zinc will destroy this hydrogen peroxide and it will give the CH2OH and CH2OH. Clear? CH2OH. You have to see very carefully, be very carefully whether they have given the zinc or not. ಈಗ ನೋಡಬೇಕು. Clear? ಈಗ ಅವರು zinc ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ this is a oxidative ozonolysis. This is a oxidative ozonolysis. Now this is a reductive ozonolysis. Clear? Oxidative ozonolysis, iduna reductive ozonolysis. Clear? Now only the one thing you have to see, whether they have given the zinc or not. ಈಗ zinc if they have given, this is zinc. ಈಗ zinc if they have given, zinc ಏನು ಮಾಡುತ್ತೆ, it will destroy the hydrogen peroxide is a mild oxidizing agent. If it is not destroyed, now this will glyoxal, instead of converting into in this product, it will be converted into formic acid. Now that formic acid, it will be converted, again it is unstable, again it will be further oxidized to the CO2. Clear? Next, if they have given in this manner 2-butane ಈಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ this is 2-butane ಈಗ 2-butane ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಏನ್ just you break the double bond and put the oxygen and now this will get alva. Now ಈಗ hydrogen peroxide, ಈಗ hydrogen peroxide, this will form the hydrogen peroxide. Now ಈಗ zinc ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ now ಏನಾಗುತ್ತೆ, this hydrogen peroxide it will be oxidized, to the, this will be oxidized to the 2-methyl C double bond O. Clear? Now this is the oxidative ozonolysis. This is oxidative ozonolysis. Clear? ಈಗ zinc ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now this will be the reductive ozonolysis. This is the reductive ozonolysis. Clear? Now that is the oxidative ozonolysis. This is the reductive ozonolysis. Break the double bond and see whether the zinc they have given. ಈಗ zinc ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now this will be converted into OH. OH. Clear? Now here this will be converted into oxidative ozonolysis. Clear? Now next with the alkaline KMnO4. Now double bond ಅಲ್ಲಿ alkene ಅಲ್ಲಿ ನೋಡಿದ್ವಲ್ವಾ, alkaline KMnO4 ಅಂದ್ರೆ ಏನು, ಬೇಯರ್ಸ್ ರಿಯೇಜೆಂಟ್. alkaline KMnO4, alkaline or dilute KMnO4 ಏನಂತಾರೆ, ಬೇಯರ್ಸ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ವಾ. now ಬೇಯರ್ಸ್ ರಿಯೇಜೆಂಟ್, now directly now own this is also same. now with the ethine with the alkaline KMnO4 at the 0 degrees, now this we will get the product. now with the ethine, with the propane, with the alkaline KMnO4, upon heating we are getting the acetaldehyde and the another product we are getting the carbonic acid. Carbonic acid is unstable, again it will be, now KMnO4 is a strong oxidizing agent alva, now this strong oxidizing agent ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, now this carbonic acid directly it will convert into H2O and it will be converted into CO2. You have to be very careful. ಈಗ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ you have to be very careful whether they are asking with the ethine or the propine. Okay, next ಈಗ acidic KMnO4 or acidified KMnO4, acidified ಈಗ acidified KMnO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ, acidified KMnO4 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ directly it will be converted into formic acid. now formic acid it is unstable, now this strong oxidizing agent it will be converted into CO2 plus H2O. Okay, now ಈಗ by this we have finished our lecture number 3 of the alkynes. now alkynes and the ಡೈಯನ್ಸ್ ನೋಡಿದೀವಲ್ವಾ. ಈಗ ಲೆಸನ್ ನಂಬರ್ 4 ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅದರಲ್ಲಿ ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಅದೆಲ್ಲ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಇಂದಾನೆ ಕೇಳ್ತಾ ಇರೋದು. ನಾವು ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ದ ಮೆನಿ ಕ್ವಶನ್ಸ್ ಫ್ರಮ್ ದಟ್. ಅದರಲ್ಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಬೆಂಜೀನ್ and how the benzene is forming. Now delocalization, which is a strong ring activating, which is a strong ring deactivating, ellano we are going to see in the lecture number 4. Okay, bye.